Find each function value if possible. We have a function given, and the name of it is f. The variable that's used as the independent variable is x, and it's defined as 5x squared minus 8x plus 6. Because this is a function, each input that we give this function, we're going to get a unique output. For example, let's start with this notation. The way you read that, that's f of 2. Function f with an input of 2. Everywhere the function has a variable, you replace it with a 2. 5 times 2 squared minus 8 times 2 plus 6. Feel free to use your calculator. You should get an output of 10. Now, because this is a function, every time you plug in a 2, you're always going to get a 10. If we change our input to -1, we still use function f, but we replace the x's with -1. 5 times -1 squared minus 8 times -1 plus 6. That gives us a grand total of 19. Again, each input presents or gives you a unique output. If you replace your input with an algebraic phrase like x plus 2, algebraic expression is probably a better way to say it, you still perform the same movements and operations. We're going to replace these two variables with x plus 2. X plus 2 quantity squared over here in purple, that's 2x plus 2's multiplied out. The result of that squaring is x squared plus 4x plus 4. Be sure to take care of exponents before you do any multiplication. Now we can distribute 5x squared plus 20x plus 20, and then we can distribute -8, -8x minus 16. Don't forget to add 6. Combining like terms, we only have 1x squared terms, so 5x squared, 20x minus 8x, that's 12x, 20 minus 16 plus 6, that's positive 10. Changing functions, we have capital V with a variable r. The name of the function is v, the independent variable is r. This is the formula for volume of a sphere, 4/3 times pi times r cubed. Let's take a look at our top left example. We're going to use an input of 2, putting 2 in for r, that's 4/3 times pi times 2 cubed. If you multiply 3 2's together, you get a product of 8. Because multiplication is commutative, you can reorder these as needed. 4/3 times 8, that's 32/3, and pi is irrational, so we're going to leave it in terms of its symbol. Upper right, our input is 3/2. 4/3 times pi times the replacement, 3/2 cubed. 3 3's have a product of 27. 3 2's have a product of 8. We're going to move pi to the end. 4/3 times 27 over 8. 4 goes into 8 twice. 3 goes into 27 9 times, and that leaves us a reduced fraction of 9/2 times pi. Finally, in the bottom right, we're replacing r with the algebraic expression 3r. So you still do the same process. Your input changes, you replace that variable with whatever is listed in parentheses. 4/3 times pi times 3r cubed. 3 3's have a product of 27. R cubed. 4/3 times 27. 3 goes into 27 9 times. 4 times 9, that's 36. Pi times r cubed. Over here in purple, 3r cubed, that's 3 r's multiplied out. In our next example, we have a function defined as f of x equals the square root of x plus 3, then plus 2. Be careful to note this is not under the square root radical. Our input of negative 3 goes right here. Square root of negative 3 plus 2. That's square root of 0 plus 2, which totals out to 2. If we change our input to 1, then we have the square root of 1 plus 3 plus 2. Square root of 4, that's 2, plus 2 is 4. And then finally, if we replace our input with an algebraic expression, such as x minus 3, then again, right here, we're going to put our x minus 3. Just replace the variable with the brand new input. Square root of x minus 3 plus 3, your 3's cancel, leaving square root of x plus 2, and this is your new output. Again, each unique input will produce a unique output. Find each function value if possible. We're going to switch over to function g of x, and we're going to define it as 1 divided by the input squared minus 9. If our input is 0, that's 1 over 0 squared minus 9. That gives us negative 9 in the denominator. Overall, this is a negative 1/9 value. Our input's 0, our output is negative 1/9. Changing our input to 3, then that tells us to use 1 over 3 squared minus 9. Two 3's have a product of 9. Minus 9 gives us 0 in the denominator, and that's undefined. That's the first time we've run into that little if possible comment. So g of 3 is undefined. It doesn't have an output. Later, we're going to discuss why 3 would not be included in the domain. It's sort of an input that does not need to be used. Going with an algebraic expression, y plus 3, we're going to replace our input location with y plus 3. 1 over y plus 3 squared minus 9. In the red ink, if we square y plus 3, that's 2 of those multiplied out. Y times y times 3, and then you switch over to 3 times y, 3 times 3, combine like terms in the middle. So your overall product is y squared plus 6y plus 9, and that's where I've put that result. We still have to subtract 9 from it. Those 9's will cancel. And our final output is 1 over y squared plus 6y.